Assalamu alaikum student. Today we discuss the topic what is the satellite orbit. The satellite can be rotated around the earth through different paths. These are called as orbit of the satellite. Now we discuss the topic that is the geostationary orbit. What is the geostationary orbit? When satellite rotate in an orbit above the equator, it is called the geostationary orbit. If the satellite rotating in this orbit has angular velocity equal to the earth angular velocity, then the satellite appear to be stationary to the point on the earth. Hence, it is called as geostationary orbit. Now we write the orbital radius of the geostationary satellite. Here we take the mass, here we take the Earth and satellite. Mass of the Earth and or planet is represented by mp and mass of the satellite is represented by ms. The angular velocity or angular velocity of the planet is represented by omega p and the angular velocity of the satellite is represented by omega s. Here is the radius of the circular path in which the satellite is moving. This is the gravitational force that is termed due to the attraction between the planet and the satellite. So now we derive the equation in order in order to keep a satellite of mass ms in a circular orbit of radius r with a constant angular velocity omega s. A centripetal force Fc need to be supplied here. Fc is equal to msac. Here ac that is equal to r omega s square. So we can write it here as ms r omega s square. Centripetal force will be provided by the force of gravitational acceleration between the planet and the satellite. So here we write F G is equal to G MP ms over R square. Here we can write Fc is equal to Fg. Fc is equal to ms r omega s square is equal to G MP ms over R square. So in final term, we can write it as R cube is equal to G MP over omega s square. If we write it in the under root form, G MP over omega s square in form of cube root. So this is the orbital radius of geostationary satellite. Radius of geo-orbital satellite. It can be write it as angular velocity omega s of satellite is related to its period of revolution ts. Hence, we can write it as omega s is equal to 2 pi over t s. For geostationary orbit, the rotational period ts of the satellite will be equal to the rotational period Tp of the planet. So we can write Ps is equal to Tp omega s is equal to 2 pi over Ts, that is can be write as 2 pi over Tp. So we know that the radius of the geostationary orbit that is equal to cube root of g mass of the planet over angular velocity of the satellite square. So it can be write it as under root cube root gravitational constant g time mass of the planet over omega s can be write it as 2 pi over Tp का whole square. So if we simplify it, so we get cube root of gravitational constant g time mass of the planet over 4 pi square here multiplies the rotational period of the planet square. So this is the orbital radius of the geostationary satellite in terms of the rotational period.